Hi all. Let's see the next topic of Unit 1, register transfer language. So now, contents will first see the basic definitions and then we move on to register transfer language, which contains registers and how the register transfer takes place. Digital computer system, it is an interconnection of digital hardware modules. And the modules can be either registers or decoders, arithmetic elements like adder, subtractor, as well as a control logic. And the various modules, these modules are interconnected with by means of a common bus system, and there are control paths to transfer the information between them in order to form a digital computer system. So if you see the registers are also one of the modules that are present in the computer system, and the operations executed on the data which is being stored in the registers, we call them as a micro operations. The operations that are performed on the data which is stored in the registers are called as micro operations. So a micro operation is an elementary operation, a basic operation which is performed on the information which is stored between one or more register in one or more registers. And the result of the operation may replace the previous binary information of a register or may be transferred to another register. It can be any type of an operation. So if you see an examples of micro operations, shift operation, count operation, clear, load. So count the number of bits in a register, clear the contents of a register, load some value into a particular register. So all these are micro operations which can be performed on the registers. And the internal hardware organization of a digital computer is best defined based upon the set of registers it contains and the function of each and every register, as well as what are the sequence of micro operations that can be performed on the information which is being stored in the register, as well as the control that initiates the sequence of micro operations. All these will specify the hardware organization of a digital computer. So next, coming to the register transfer language. So a register transfer language is basically a symbolic notation that is used to describe the micro operations that can be performed among the registers. We also name it as RTL. Register transfer language is used to describe or explain about the micro operations that are performed among the registers. So, a register transfer language is a system for expressing in symbolic form the micro operation sequences among the registers. So, it is one of a more convenient tool for describing the internal organization of a digital computer in a precise and concise manner. So, let's know about registers. So computer registers, they are designated by uppercase letters. You can name the register by means of an uppercase letter to denote the function of that particular register. So for example, if you take a register that holds the address of the memory location. So what do we name that particular register as? MAR, memory address register, or we can also call it as an address register. So MAR is nothing but the name that is assigned to a particular register that holds the address of the memory location. So like that, you can name the particular register by means of an uppercase letters. So if you take another examples of the registers present in a computer, PC stands for a program counter, and IR stands for instruction register. So all the names of the registers, they can be given as uppercase letters, or if you want to take general purpose, there will be, apart from this we have some general purpose registers that are used for intermediate computations. So like R1, R2, R3, like that. Those registers can be named as R1, R2, R3. These are the processor registers that are used during the execution of instructions by the CPU. So they can be named as R1, R2, so on. And coming to the bits in a register, if you take an n-bit register, it can be numbered in a sequence from 0 to n minus 1. So the starting of the bits in a register starts from 0 in the rightmost position and increasing the number towards the left. So if I take a 16-bit register, the numbering of the bits in the register starts from bit 0, so on up to bit 15. So that is represented by a 16-bit register. So if you see this, this is a block diagram of a register. So there are different ways in which you can represent a register. So a register, if you see here, in the first one, the register R1. So the register can be named like this as a register R1, naming. So you can also represent a register by showing the individual bits. So if this is consider this as an 8-bit register, the individual bits of the registers are numbered like this 0, 1, 2, 3, 4, 5, 6, 7. So it shows the individual bits of a register. The other way of representing is the numbering of the bits. If you consider this a register R2, which is a 16-bit register, the numbering of the bits starts from bit 0 to bit 15. And the other way of representing a register is dividing it into two parts. So the register, the 16-bit register is divided into two parts where 0 to 7-bit represent the low level bits. Consider this is a program counter. This register is a program counter, which is a 16-bit register. The lower bits 0 to 7 are represented by capital L, the low level bits, and higher level bits are represented by from 8 to bit 18 to 15 are represented by H. So these are the different ways of representing a register in a computer system. Next, coming to a register transfer. So register transfer is nothing but it is a method of transferring the information from one register to another register. And this transfer of information will be represented by a symbol arrow like this, reverse arrow. We call this as a replacement operator. So this replacement operator is used to denote the transfer of information from one register to another register. So the statement, if you say, for example, if you take the statement R2 replacement operator R1, it means that it transfers the contents of register R1 into register R2. So it designates a replacement of the contents of R2 by the contents of register R1. Say for example, I have contents of R2 as 000 and contents of R1 as 111. So when I implement this particular statement, the contents of the register R2 becomes 111. So they are replaced with contents of R1. But what about the contents of R1? They remains the same. It will still have a copy of 111. So, but it is going to replace the contents of the destination register. So the contents of the source register R1 does not change after the transfer. So here the register transfer is mainly implemented by means of an operator called replacement operator. So if we want to transfer to occur only under certain predetermined control condition, then you can implement it using a statement called if then statement. So if P is equal to 1, P is a condition. If it is satisfied equal to 1, then only this particular transfer operation has to take place. That means then only the contents of R2 will be replaced with the contents of R1. So under a certain condition, if the particular transfer operation has to take place, then it can be implemented like using a if then else statement, or it can also be implemented by means of a control function. So a control function, P is nothing but a control function, which is a boolean variable that takes a value of true or false or 0 or 1. 0 means false and 1 means true. So depending upon the control function, this particular uh, this particular transfer operation will take place. So control condition is terminated by a colon, implies the transfer operation will be executed by the hardware only under this if P is equal to 1, if the condition is satisfied. We'll see this with the help of a block diagram. So P is nothing but a control function and R1, R2 are the registers n bit registers of R1 are connected to n bit inputs of R2 register, and R2 register has a load input connected. So the control circuit will generate the signal only if the particular condition is satisfied, so that the load input will be active. So whenever the load input is active, the clock pulse will be applied, or the timing signal will be applied, and the contents of the information or the contents of R1 register will be transferred to the contents of R2 register. So the transfer occurs from R1 to R2 only if the control function is satisfied and when the load input is active. Then the clock pulse will be applied and the transfer takes place. So this is the timing diagram that for this particular block diagram. So this is a clock pulse. This is a time t. This is upward direction. The clock pulse towards upward direction. So timing signal t, and this is t plus 1. So the load input, the control function P will be active at a timing signal T, but the load input takes one clock cycle to get executed. So at a clock cycle T plus 1, the actual transfer of information takes place from R1 to R2. But the load input will be active, the control function will be active, and the load input will be triggered, and it takes one clock cycle to start the initiation of transfer of information. So the transfer occurs only at the timing signal t plus 1. So this is a timing diagram for that particular instruction. So the n outputs of register R1 are connected to the n outputs of register R2. The letter n will be used to indicate any number of bits for the register depending upon the number of bits of your register, whether it is 8-bit register or a 16-bit register or whatever it is. The register R2 has a load input that is activated by the control variable P. Only the load input will be active only if the control variable P is equal to 1. So if you see the timing diagram, the P is activated in the control section by the rising edge of the clock pulse at the time t. So at a time t, P will be active. This we call it as a rising edge. The upward clock pulse is a rising edge. The next positive transition of the clock at t plus 1 finds the load input in active. So it takes one clock cycle to make the load input active. Only at t plus 1 the timing signal, the load input will be active, and the actual data transfer takes place from R2 to R1. So P may go back to 0 at a t plus 1. P is only when P is equal to 1, the load input is active. At time t plus 1, P has to go back to 0. Otherwise, the transfer will occur for each and every clock cycle when P remains 1. So at time t plus 1, once it is at load input is active, the P again becomes 0. Even though the control condition P becomes active just at time t, the actual transfer does not occur because it takes one clock cycle to start the transfer of information. So until the register is triggered by the next positive transition at t plus 1. So next see the basic symbols for register transfer. So to perform a register transfer operation, some symbols have to be mentioned. So letters. So to denote a register, we have to make use of a letters and numerals as well. Some registers they can be defined like this, where some registers can be given in the form of R1, R2 like that. Next, parenthesis denotes a part of a register. So if you want to perform an operation only on certain bits of a particular register, then you can specify like this, R2 of 0 to 7. Suppose if it is a 16-bit register, you want to replace the contents only with the first 7 bits, 8 bits. So you can write it as R2 of 0 to 7. So or you want to perform it on the only left half. So like that, R2 of L that can be represented like this. The arrow denotes the transfer of information. So R2 arrow R1 means contents of R1 has to be transferred to the contents of register R2. And comma separates two micro operations. So this is one micro operation that is performing a transfer of information. This is one micro operation. They can be separated if both the operations are taking place in a single clock cycle. They can be separated using a comma. So a comma is used to separate two or more operations that are executed at the same time. Okay, so if you see here, these are the two operations denotes an operation that exchange the contents of two registers. So the contents of R1 register is first moved to the contents of R2 register and R2 is moved to the R1 register. So this is about register and register transfer. Thank you.